This video is an intermediate lesson in file system permissions with a focus on directory permissions. I introduced the topic of Linux file system permissions in a previous lesson, where I discussed permissions as applicable to regular files, including how to set them using the symbolic method. You may want to check this video out first if you are not comfortable with the general concept of permissions yet. It may be worth it to define what directories are before I actually get into their permissions. Directories are special files where the purpose is to store information about other files. While some people use the term folder as equivalent to directory, the term directory is more appropriate as it better describes how this special file works. Also, the directory term is directly reflected in shell commands. We have make directory and change directory, and not make folder and change folder commands. While it is perfectly acceptable to say things such as directory has files or I created a file in a directory, technical users need to know that such phrases do not reflect what the operating system does. Directories do not actually store files, but mere references to files. What we see by observing a file system listing is a high-level abstraction, including how the file system is visualized as a hierarchical structure. Directories allow us to organize and name files, otherwise we would be facing a flat list of thousands of numerical storage device locations which human brain could not possibly process. In simplified terms, a directory is like a table with two columns. One column holds file names listed under it, while the other column holds corresponding numerical addresses on the storage device associated with each file. Each directory on the Linux file system has a set of permissions just like regular files, where we use R, W, and X flags to describe them. However, the effect of these flags is different for directories than for regular files. In general, permission flags for regular files control what we can do with file contents. Permission flags on a directory control what happens with files listed under that directory. Directory permissions follow the hierarchical structure of the file system. Adding the -a option to the ls command gives us a full picture through the two hidden dot and dot entries in each directory. For example, here the dot entry shows permissions for my example directory, controlling access to ABC file and XYZ directory contained under. The dot entry shows permissions of the parent directory, controlling access to the example directory itself. The XYZ directory permissions in turn control what happens with files inside that, and so on. The R read flag allows us to read the directory, allowing us to see which files are listed in a directory. Commands such as ls, tree, and find rely on this permission to function. The W write flag allows us to change a directory. With this permission in place, we can add entries to directory by creating files under it, or we can change a directory by renaming or removing files listed under a directory. Just to make it clear, when I say files, I include directories in that term. As I already said, directories are files too, they are just special. When it comes to directories, the execute flag is called pass-through or search, and it controls whether we can enter a directory, either directly through the cd command, indirectly by using the directory in a path name, or by using a command such as find. We typically have full permissions to directories we own: read, write, and pass-through, which is the default on most systems. Removing read or pass-through permissions for directories we own does not make practical sense, but sometimes we remove the write flag from a directory to prevent ourselves from removing, renaming, or creating additional files inside it. Changing directory permissions for group and others is more common, especially if your default permissions, as applied to newly created directories, give access to group or others. For example, on my system, when I create a new directory, group and others get read and pass-through permissions by default. It is the purpose of this video to help you understand the implications of this situation and how to change it to secure your files. I will demonstrate how to use permissions to control access for other users, but any concepts I will discuss apply to group permissions in the same manner. I have here a directory called example with some files in it. I'm logged in as user Pi, who is the owner of this directory and all files inside. User Alice is not a member of my user group, so access to this directory for Alice is controlled by others' permissions. Currently, others can read and enter the example directory as they have read and pass-through flags set. Let's confirm the effects of current permissions on user Alice. Alice can list the directory contents using the ls command. Check. Alice can also enter the directory using the cd command. Check. Let me take away the read permission from others now. Now, when user Alice tries to use the ls command, it comes back with a permission denied message. It is very important to know that this does not prevent the other users, such as Alice, from accessing files inside this directory. Files can be accessed as long as the individual file permissions allow it if Alice knows or guesses file names in here. For example, Alice can copy the ABC file without a problem. This is possible because the pass-through X permission for others is set. Removing the R read flag from directories is a common method to share files with others without allowing them to look around. They will be able to access files in such directory if they know their names. Keep in mind that this approach is not 100% secure, as it is necessary to give access to the entire directory, and persistent or lucky users may figure out other file names present in there. How about if I remove the pass-through X flag? Let's see what will happen then with Alice user. Although Alice is already inside the directory, an attempt to access the ABC file again now results in permission denied message. The ABC file permissions have not changed, but the directory permissions are checked first before individual file permissions are applied. Users who do not have pass-through access to a directory cannot access files inside. Should Alice leave the example directory, returning to it is not possible until permissions are reset. The X pass-through permission on a directory is an effective method to restrict access to anything below that directory level. There's no need to change permissions to any subdirectories to limit access to them, as users are literally unable to pass through the directory with the X flag taken away above in order to reach any level below. Alright, let me restore the others permissions to the example directory. Actually, while I'm at it, I will also give others the W write permission. This is not something you would see often, as now others, which is effectively anyone that can access your system locally or remotely, have full control over the directory contents. So don't try this at home and watch carefully. User Alice can now create new files inside this directory. Alice can also rename files in this directory, including files owned by me. Note that the renamed file did not change ownership. Perhaps the most important takeaway from this situation is that user Alice can even remove files from example directory, again, including ones owned by me. Let me sum it up. As soon as you give others, or the group for that matter, write access to a directory, you are giving away full control over the directory contents. By the way, since I have write permission to example directory myself, I can also remove Alice's files listed there. It is very important to realize, as I just demonstrated, permissions on files themselves do not control whether files can be renamed or removed, and individual file ownership does not matter here either. The courtesy message you have seen about deleting a write-protected file is associated with the individual file permissions and not the container directory permissions. This is a common misconception where users believe that taking write permissions away from a file would prevent the file from being removed. Using the -F force option with the rm command suppresses that warning. Whether an individual file is write protected or not refers to file content, not whether the file exists at all or what name it has. These attributes are controlled by container directory permissions, as this is where that information is stored. In general, you should not give write permissions to your directories to group or others as default. Other than opening yourself for data loss, giving directory write access to other users creates a serious security hole, as it allows introduction of Trojan horse files inside your directories. Other users can replace your files with ones named identically. This is particularly problematic if a replaced file happens to be a program. That's it for this video. Understanding and using directory permissions correctly is at the core of file system security, and I hope that watching this lesson will help you stay secure from now on. Thanks for watching.